So what happens as the insulation degrades over time? This is a good example of how the motor or insulation fails over time. In the beginning, remember we spoke about the turn-to-turn insulation. We said it's 8 kV minimum. So this is the dielectric strength between turns. And this is day one, and hopefully this is 20 or 30 years life of the motor. So the insulation will degrade naturally because of heat, moisture, vibration, anything, as chemicals maybe. You can't stop that. The insulation will degrade always. The question is how quickly. This is 400 volts. This is the operating voltage of the motor. This is the test voltage 2000. And these are the switching surges that the motor sees during starting and stopping. Okay? So at this point, when we have good insulation, the switching surges can be very high and it doesn't actually cause a problem because the insulation strength is sufficiently high. But over time, the insulation will degrade. And when you come to this area, you have more risk because now the insulation strength is lower and it's similar to the switching surges. So when you have a switching surge at the same level as the dielectric strength, you have arcing between turns, like my motor. Like you saw in the video, you saw the arcing. And the arcing leads to the insulation becoming lower and lower and lower. Okay? Eventually, instead of arcing, the turns will weld together and you have a short circuit. In the UK we say dead short. So we have two wires which are welded together, and that welded connection makes a transformer, an auto transformer. So you induce very, very high current here, and the high current means heat. Heat will burn away the insulation around the fault area, and eventually it will burn the slot paper. And when the slot paper burns, you have a fault to ground. So now, if you use your mega test, you can see the problem. But we need to, that's too late. The motor is tripped already. We need to find the problem before we have the short circuit. We need to find weak insulation. Okay? There's a comment here. So this is a member of IEEE in America. He states, when you have a short circuit inside a motor, the motor will fail within 15 minutes. Okay? So you have 15 minutes only to take your mega tester and to find the problem to ground. So I have a video which is quite interesting. So this is an experiment performed at Oregon State University by a guy that used to work for Baker. Unfortunately, he was killed in a road accident a few years ago. But basically, what we've done, we have wound a motor. So this motor has been rewound, and it has a short circuit inside. It's been designed with a fault. Okay? The short circuit is connected here to a switch. The switch is now open, which means there's no short circuit. Okay? The motor is being load tested. Here is a coupling, here is a load. So the motor is running at 100% load. Okay? We're measuring the three-phase currents here, making sure we have balance. Okay? And in the video, when I run the video, you will see someone hit the switch, and when the switch closes, we have a short circuit inside the motor. And then we will see what happens. Okay? So this is really demonstrating what happens when the motor has a short circuit in your plants. What happens? Okay, so now there's a short circuit inside the motor. The time is here, 45 seconds. He says the currents are not showing the problem. There's a short circuit in the winding, the currents are still balanced. So this is a 100% load test. The three phases are balanced, even though there's a short circuit inside. "45 seconds. So the motor is finished. So once you have a short circuit in the motor, you have very short time left of the motor's life.
And this motor is loaded.
100% loaded.
100% loaded.
Yep. Okay, so the video showed 45 seconds and then the motor burnt. This guy says 15 minutes. It doesn't matter whether it's 45 seconds or 15 minutes or 1 day or 2 days. It means you have very, very short time left before the motor fails. So we need to find the problem before you have a short circuit. And the only way to do that is to use a surge test. Otherwise you can't find weak insulation. Parsons' law of physics tells you you cannot find a turn-to-turn problem with a megohm test. And the earlier video I showed you proved that. We had 8 gigohms on the megohm test, but the surge test showed the problem. So this is my main aim today, is just to explain how the surge test can help you. Okay? What's the time? Time for a break. There's one other thing we didn't cover, just briefly. One thing we didn't cover about the megohm test, we looked at the standard for voltage. Okay, so we discussed that, and we agreed that your company followed the standards for voltage, which is very good. What's the minimum megohm value that you look for when you make a megohm test? So when you make a megohm test on your motors, what's the minimum megohm value that you look for? One? What's the minimum megohm value that you are happy for the motor to run at? Okay, yeah, it should be infinity, yeah, but the minimum. What's the minimum you are happy with?
2 megawatt for 1 kilo 1 meter.
2 megawatt.
1 megohm plus 1 megohm per kV.
6 kV 7 meter.
Okay. So the standard, this is the standard. Recommended safe minimum megohm values. Okay, so my stator is random wound after 1974. So the standard says 5 megohms is safe. Okay, do you agree? I don't agree. For high voltage it's different. High voltage, this is now full wound. Remember the diamond coils I showed you in the beginning? Special coils for high voltage machines? 100 megohms minimum. This is the standard. So instead of 7, better is 100. Better is higher though, in my opinion. Also, you have to understand the standard talks about 40-degree correction. So when you make a megohm test, you have to measure the temperature of your winding. So maybe it's 30 degrees, and you make a correction to 40 degrees. Because every 10 degrees Celsius increase in temperature, the megohm value is halving. So temperature makes a big difference. So the standard for high voltage motors is 100 megohms at 40 degrees. And if you want to make a trend of your megohm values over many years, you have to correct for temperature. Okay? And I'll show you one example. This is an example of a test I did on a ship a couple of years ago. So it's a thruster motor, 690 volt, about 1 megawatt, approximately, 1.5 megawatt. Okay? So I did a winding resistance test, phase to phase. Okay? Very low resistance. And the balance was 0.79%. So I know my connections are good and my windings are balanced. That's the first step. Then I make a megohm test. 500 volts, 5.9 microns of leakage means 86 megohms. Okay? 86 megohms at 23 degrees. Okay? Our tester makes a calculation for 40 degrees automatically. So at 40 degrees, we only have 26 megohms. Quite low. But what's the standard? This is a random wound motor.
Standard says 5.
The standard says 5. Okay? Or if it's a full wound winding, low voltage, 100. So that should be okay. The standard says that's okay. But when we looked at the problem, this is what was happening. These earthing straps are between the phase cables. Every phase has 6 cables. And basically what happens is you have 2 cables and you have the earthing strap, and they're very tight. When the ship is working, you have lots of vibration. And basically it's cutting the insulation. And that's what this is. You can see here the dust. It's coming from here. These earthing straps are cutting the insulation and lowering the insulation resistance. And that ship was 18 months old only. So in 18 months, our megohm value has come down from 20 or 30, 40 gigohms to 26 megohms. And the standard says it's okay. But that motor, or that cable would have failed pretty quickly. So what I'm saying to you, although the standards give you values, sometimes you have to make better values than the standards for more reliability. If you want your motors to be reliable, you need to have a higher megohm value. And then you can see the problem coming. Okay, my tester, for this failure, this is automatic failure. The tester will stop and tell you you have a problem with minimum megohm. In my program, I use 50 megohms at 40 degrees. That's my standard. So my standard is 10 times the international standard. That's why the value is red. So this is a very simple case study, but it shows you that you need higher values for reliability. And then one case study for surge. Okay, it's a very simple graphic. This is how we connect to a 3-phase motor on site. In the switch room, on the output side of the contactor, testing through the cable into the motor. That's how we test. If you find a problem with any of the tests, testing in this method, you have to test the motor on its own without the cable. And then you can identify, does the motor have the problem or does the cable have the problem? Okay? So this is the surge test. This is the response we have on the screen from the surge test. So it's based on the inductance of the winding. So the 3 phases should give you a very similar response. Okay? When we have arcing between turns, because the voltage is jumping across the turns, it changes the inductance of the winding. And that changes the response of the surge test. So our waveform is moving from here to here, it moves to the left. This is how we know there's a problem. And we have some special software which shows the problem. This spike tells me I have a problem on my phase. So we know which phase, or it could be two phases. It could be a phase-to-phase problem, or it could be a problem inside one phase. But this is telling me I have weak insulation. Very simple.
By being of phase to phase, you mean turn in this phase and the turn in this phase, right?
Yes.
Yeah.
And you can find a phase-to-phase problem with a megohm test. I agree. But your voltage has to be very high. Okay. I cannot find a phase-to-phase problem on my motor with a megohm test because my star connection is inside. I can't open the star connection. So if I make a megohm test on this motor, I have a short circuit. It's impossible. But I can make a phase-to-phase test with surge. So this is the difference. So this is a typical test on site. This is a 12 kV tester. I'm testing, it's not me, it's my colleague, testing a generator, 6.6 kV. Okay? This is the generator. This is the generator, and this is a coolant system on top. This is in the engine room of a ship. So basically we did a test. Winding resistance is very unbalanced, 18%. Most three-phase motors, so this, for example, is 0.3%, 0.3% unbalanced. Most motors are less than 1% unbalanced. This winding was 18%. It's the three-phase exciter rotor in a generator. We investigated with the customer and we took a picture with a boroscope going inside the machine and we could see some colouring has changed. So then we took apart the machine and that's what we found. You can see here there is copper missing from the circuit and we have burning here, here, here. The winding is burning. But the generator could still work. The generator was working, the customer had no problems with the generator at all. But there's a problem coming. There's a very big problem coming. So
And it will come suddenly.
it will come suddenly and he will lose the ship. This is a thruster motor to control the position of the ship. And if you lose a thruster motor, it can be very serious.
How do we move this fault?
Sorry?
How do we move this fault?
You have to rewind completely. Take out the windings and make a new winding. No other possibility.
Not use this winding.
No, new winding, completely new. Yeah. Okay, so one more case study. So this motor is 4,000 horsepower. High voltage, 4,000 horsepower. It's in a company in America, in a mining company. Okay, this is the motor. You can see it's a slip ring motor. The motor has been in stock for 3 years. It's a spare part. It's a critical spare. So it's a very important spare. If the motor in production fails, they will put this motor into production straight away to save time. And the plan was to fit the motor in 2 weeks' time. They wanted to change the motors. So the engineer decided to test the motor first because it sat there for 3 years and he wanted to make sure, is the motor I'm going to fit in a good condition? So he made a test. He measured the phase-to-phase resistance and he had 3.5%. Okay, for me it's a little high. For me, it should be less than 3%, but okay, we can accept it. We can accept. Megohm test. Now the motor is 4160. American motor, 4,160 volts. High voltage. Megohm voltage is 5 kV, correct. He had 8.3 gigaohms at 36 degrees, and at 40 degrees he had 5 gigaohms. So this is a good value. 5 gigaohms is very good. He made a PI test at 5 kV. The PI ratio was 7.5. That's also very good. He then did a DC high pot test, not step, but high pot, it's similar. 9.3 kV. It's a DC high voltage test. It's like a high voltage mega, but at 9.3 kV. 2 times plus 1,000.
The resistance was insulation
5 kV.
10 power 6 5,000
So this is the voltage, 5 kV DC, and this is the insulation resistance. So voltage divided by current gives you resistance. So this is megohms, 8,000 megohms, or 8 gigaohms.
هو رد على سؤال حضرتك. هو القيمه اللي خدها هنا بعد ما عمل الانسوليشن تيستنج ب 5 كيلو، فالقيمه اللي طالعه 8333 ميجا اوم اللي هي 8 جيجا اوم. هو المفروض ان الموتور ده جديد. ما هو الستاندرد بيقول ان الموتور يقيم ان هو كويس لو العزل بتاعه اكبر من 5 ميجا. لا ده ستاندرد منه يعني من الحدود اللي هي اقل حاجه ان هي تكون 5 ميجا فيما فوق ده يبقى كويس. فهو الانسوليشن ريزيستنس هنا طبعا بشكل جيد جدا اللي هي 8 جيجا. بس 8 جيجا ديت كانت متقاسه عند كام؟ عند 36.7 ديجري. فهو الستاندرد بيقول ان هي تبقى 5 ميجا او اكبر عند 40 درجه مئويه سلسيوس. فهو السوفت وير بتاع الانسترومنت بيعمل الكوريكشن، بيقدر ان هو القيمه اللي انت بتقيس عندها الريزيستنس او اللي هي الانسوليشن ريزيستنس يقدر ان هو يجيب لك القيمه الحقيقيه عند 40 درجه. وبالتالي
مش طريقه ثانيه، هو كيس ثانيه في بعض المواتير الكبيره الهاي فولتج اللي ليها فورمينج، يعني ليها فورمه معينه في الوايندنج يبقى مينيمم 100 العزله. حركات الهاي فولتج
عايز يقول لحضرتك بعد 5 مليون دي ستاندرد، ولكن هي مش حقيقيه. كيس صوب الالات كده بتاعت 26 مش
بس هي كويسه. ده شيء كويس ان انت كل ما الانسوليشن ريزيستنس بتاعتك عاليه معناها ان انا الهاي فولتج بتاع المحرك معزول عزل جيد جدا عن جسم المحرك. فكل ما الاكس كارنت بيكون اقل او الانسوليشن ريزيستنس عاليه معناها ان المحرك بتاعي في جيد جدا وان هو هيسيرف في الخدمه لوقت طويل قوي بدون ما يحصل فيه مشكله. بس هو في واقع الامر هو احنا عايزين نميز ونوضح ان السيرش تيست هو شيء مهم جدا عشان اجيب الهيدن ديفكتس الموجوده جوه المحرك بتاعي. وبالتالي هو لما كان بيتكلم عن التيست ستادي اللي بيتكلم فيها على الموتور دوت، والموتور ده كان سبير موجود على سفينه، والسفينه يعني موجوده في البحر، وبعدين قرروا ان هم يغيروا المحرك نظرا لان في مشكله قائمه فيه. فالموتور اللي هو كان موجود في الستوك بتاعهم حاولوا ان هم يختبروه الاول قبل ما يركبوه بشكل فعلي في مكان المحرك اللي في الخدمه دلوقتي. فهم جمعوا عليه الاختبارات، لقوا ان الانسوليشن ريزيستنس بتاعته ما بين الفيزز وبعضيها جيده، وما بين كل فيز والجسم المحرك موجوده بشكل جيد. وقيم الميجا اوم بالانسوليشن ريزيستنس جيده، والبولاريزيشن اندكس مدى قيمه 7.5، معناها ان المحرك ده العزل بتاعه جيد جدا. مظبوط.
10
ميجا ديت 8000 ميجا.
Yeah, this is 8,000 mega ohm. 8,000 mega ohm, so 8 giga ohm. So very high. Anyway, it's good.
وبعد ما عمل كافه الاختبارات عليه او الهايبو تيستنج اللي هو يعني عمل نفذه عند جهد 9.3 او 9.4 كيلو فولت على المحرك بتاعه، لقى برضه ان قيمه الانسوليشن ريزيستنس طالعه بشكل جيد جدا. لما عمل السيرج تيستنج على المحرك اللي هو موجود في المخزن اللي هو موجود على السفينه ديت، لقى ان في قيم طبعا ما هياش جيده تماما. الفيز الاولانيه طبعا الجهد بتاعها 9.3، والفيز الثانيه مديه جهد 4.3 كيلو فولت، تحملت الجهد ده بس وحصل اركنج والجهاز عمل فيل. فديت معناها ده محرك جديد، يعني انا ما اشتغلش عشان يبقى في مشكله تحصل بهذا الشكل وان يكون في جهد فيز كسرت عند رقم قليل. فلما عملوا انفستيجيشن على المحرك دوت.
Okay, so what I want to show you, the most important thing, the customer tested the motor. The motor is 4,160. He tested the motor at twice the rated voltage plus 1,000. This is the standard. And he had 13,000 mega ohms, or at 40 degrees, 8,000. Okay, so at 9,000 volts we saw no problem with DC voltage. But when we performed the surge test, we saw a problem at 4,000 volts. Because the tests are different. The DC voltage is looking for leakage to earth. The surge test is looking for turn-to-turn problems. And there was a turn-to-turn problem. Now this motor was assembled. Remember the picture. The customer can't see inside the motor. But the tester is telling him, you have a problem in your motor. You have to make an investigation. When they investigated, turn-to-turn insulation problem. We think inside was a mouse or a rat, because the motor is open. Here is open. Here is the winding. So a mouse or a rat can come inside here and it can eat the insulation. This is the only explanation, because this is not caused by moisture. This is caused by something eating the insulation. Okay, so if you make a resistance test and a mega ohm test and a PI test, you will put the motor into service. And at this voltage, the motor would fail immediately, probably immediately on starting, because the voltage is so low. But with the surge test, we know there's a problem. This is very important.
What's the meaning of the last search? Maximum
So this is how we okay, so we compare how much the waveforms are separated. So we have two tolerances. One is called line to line, and we compare the area separation. And the second one is this one, pulse to pulse EAR. This is a tolerance. So if this breaks through the line, the test will stop automatically. But even though this has not broken the line, this is still a problem. So it's basically how we analyze the data. When we sell equipment, we give training on how to analyze and how to use. That's quite a big subject, but basically that's what it means. Okay, so what would have happened if this motor had gone into service? This is the most important thing.
This motor can serve for time. Time, but not volt.
Sorry, say again?
الموتور يعني هيحصل مشكلة بعد كده.
هو
This motor can work for time.
I don't think so.
هي المشكله اللي هو كان بيتكلم عليها دلوقتي ان هو الموتور ده كان موجود على مركب فعلا، وان هو معمول ريزيرف للموتور، المين موتور اللي هو موجود في السفينه. محتاجين ان هم يركبوا الموتور الريزيرف دوت في مكان الموتور الاساسي الموجود في السفينه. فلما عملوا عليه الاختبارات لقوا ان قيمه الريسيرش هي فيها مشكله، فاضطروا ان هم يدسوا السن اللي بقى الموتور ده، فطلع الروتور اللي جواه، لقوا ان الاستيتور نفسه من فتحات موجوده جوه الجسم المحرك في فئران دخلت وابتدت تاكل في العزل بتاع الوايندنج في الكويلز بتاعت المحرك. اضعفت العزل لغايه ما خلت ان بقى التيرن فيها مشكله. وبالتالي هو بيقول ان هو بالاختبار دوت
بعد فترة قليلة
لا مش فتره قليله، هو مجرد ما يركب هيحصل
يعني خلاص.
مجرد ما يتحط على اللود هيفيل في وزن دقيقه او 10 يعني فورا.
ايه اهم الاسباب بقى؟ ايه اهم الاسباب اللي بتحصل
اللي هو الفيلير ما بين اللي هو عشانها استخدم جهاز السيرش تيستر، ان يكون في عزل حصل فيه مشكله ما بين نفس الملف او ملف ومن فيز لفيز اخرى. ده بيجي مننا الويكنس بتاعت العزل ديت، ان هو ممكن من السخونيه بتاعت المحرك، ميكانيكال موفمنت بتاعت المحرك او الدوران بتاع المحرك ابتدى في
انا عايز اقول لك ان انت الموضوع كله على العزل.
الموضوع كله عزل دلوقتي،
يعني ما يرجعش الماتيريال نفسه النحاس ان ممكن يبقى فيه خطأ نفسه في المنطقه دي.
هو انت من حيث المبدا
الماتيريال نفسه
في نفس قيمه النحاس.
النحاس نفسه، يعني انا عندي هما اثنين، عامل ايه؟ اما العزل او النحاس نفسه في مشكله، الالويز نفسها في المنطقه دي. اشمعنى المنطقه دي بالذات؟ حاجتين،
اما النحاس
بس الالويز نفسها في المنطقه دي مش تمام،
مش جيد. المهم في كلتا الاحوال
سرعه في التيار هنا ممكن
ان هو يحصل اوفر كارنت في المنطقه ديت، او ان هي الريزستنس بتاعتها عاليه شويه.
بس نرمي الموضوع كله على العزل.
لا هو في الاخر
في الماتيريال نفسه.
ما هو حتى لو في الماتيريال نفسها فهيأثر على الماده العازله اللي معمول منها الملفوفه على السلك.
ايوه،
وبالتالي
العزل كله ما السلك كله معزول زي بعض. هو اكيد طالع بس قاس وله وشغله. الماتيريال اللي جوه برضه معمول لها كل حاجه، بس ممكن يكون الخطأ في النقطه في الماتيريال نفسه، مش شكل، مش العزل بس. العزل ده بتيجي عند الكراكات او
اللي فيها بندنج بالظبط.
يعني كل الموضوع عند
ولما بيحصل المساله ديت فهو بيأثر برضه على الماده العازله. الماده العازله او الانسوليشن تيستنج او الانسوليشن هي الاختبار الاول اللي بيتعمل على اي مهمه كهربائيه، من اول الكابلات لغايه المحولات الكبيره اللي هي موجوده في محطات الكهرباء، محطات الانتاج نفسها. لو انا العزل بتاعي ما هوش جيد، او ان هو التست فين في اول اختبار للعزل، ما بكملش بقيه الاختبارات بتاعتي، ما اعملش فانكشنال تيست لاي حاجه. ليه؟ لان هو ده الاساس بتاعنا في الشغل.
كل فكري ان ممكن يكون العيب نفسه في السلك نفسه منطقه معينه.
حلو، حتى لو حصل ده فهي هتاثر على الماده العازله نفسها. الورنيش ممكن يسخن ان هو يدوب الورنيش الموجود عليها، وفي الاخر هيحصل ان يبقى فيه اتصال.
انتوا كشركه بتعملوا التيست دوت، الاخطاء دي بتعرفوها بتتحل الاخطاء دي هل هو الورنيش فعلا ولا الماتيريال بقى؟
ما هو
احنا الاثنين يعني
احنا بنقول لحضرتك بالظبط هو نعم
لازم يحصل اول اختبار للعزل بناء عليه انا بكمل الاختبارات بتاعتي او لا.
مش بتاعتهم
تمام.
مش بتاعتهم.
احنا بنقول ان هو الاختبار بتاع العزل او الميجا اوم ما هوش كافي بس الاختبار المحرك بتاعنا، وبالتالي بقى في مجموعه اختبارات اخرى موجوده جوه الجهاز بتقدر ان هي تحلل الاعطال الموجوده فيه الهيدن اللي انا ما اناش شايفها، ولما نظهرها حضرتك تقدر تاخد قرار في ان انت تصلح المحرك بتاعك. تقول ان انا عايز الف المحرك او ان الفيز دي نفسها فيها مشكله فانا ابتدي اتعامل معاها، او ان السلك نفسه لغايه الروزيتا او لغايه اللوحه اللي انا بختبر من عندها فيها مشكله، فاقدر احل المشكله بتاعتي في الوظيفه.
جهاز واحد ممكن يديني كل فرق.
هو احنا في السيشن الاولانيه اللي احنا شغالين فيها دلوقتي كل ده بنتكلم على الستاتيك تيستنج اللي هو معني بالعزل بتاع المحرك. السيشن الثانيه اللي هيقوم بيها مستر مايك هيتكلم فيها على الدايناميك تيستنج، ان الموتور بتاعي راكب اون لاين ولودد وانا بعمل فول اناليسيس
That's after the break.
but after the short break.
Okay, let me finish this slide and then we can have a break. So, what I wanted to explain is the financial benefit of the test. This motor would cost $44,000 per hour if it fails. Per hour. So if you think about the surge test voltage, we found the problem at 4,300 volts, almost line voltage. I would say this motor would fail immediately or almost immediately. It takes 24 hours to fit the motor, just to fit the motor. 24 times 40,000. Okay, that's the first cost. This motor was the only spare motor. So if the spare motor fails, they have no spare motor. To repair that motor would probably take 2 months, maybe. One and a half to 2 months, times $40,000 per hour. So that test
Save money.
has saved a lot of money. What did we calculate yesterday?
It was for 2 months. It was 1 million.
£1 million or dollars. $1 million. Okay, not every motor is like this, but this gives you the understanding of the importance of reliability testing. We can find these problems that are coming that will cause your motor to fail before they fail, and you can make a plan to change the motor at the most convenient time. Okay, so that's static testing. I hope that was interesting. We have a break and then we'll talk after the break about dynamic testing.
يعني احنا ان شاء الله باذن الله بريك 5 دقائق في مكاننا، هنوزع لحضراتكم درينك بسيط كده اهوت، وهنكمل الاستاتيك لساعه واحده، وبعد كده ان شاء الله باذن الله تخلص ان شاء الله باذن الله.
ساعة بس.
احنا هنخلص الساعه واحده ان شاء الله. ممكن تصلي بعد الساعه؟ ممدوده لحد العصر. هي ممدوده لحد العصر غالبا. ماشي. هنوزع على حضراتكم كوتشنير او الكوتشنير اللي عند حضراتكم دلوقتي ممكن تملوه خلال او ممكن بعد البريك افضل. عشان لسه في جزء تاني دايناميك. ماشي.